All right, I'd like to make a quick video on how to use your graphing calculator, TI-84 specifically, to find limits. So here's an emulator for a TI-84. Looks something like this. And what we're going to do is we're going to start by hitting the y equals button. So we're in the function editor, and we're going to put in a function that if you plugged in directly, you would get indeterminate form of functions, so it would be harder to know. But this is what the function would look like. We're going to use parentheses. We're going to say the square root. So hit second, and then this button here, square root of x plus 1. And then we have to hit this right arrow to get outside the square root, and then minus 1. And then parentheses divided by x. And we're basically going to try to look at the limit as x approaches 0. So if you plug it in directly, you get 0 over 0, which is indeterminate and not defined. But if we go to graph it, it looks something like that, which is kind of hard to see. So what we can do is we can start with hitting zoom and go to zoom, go down to zoom fit, see what that gives us, hit enter. And we get something that looks a lot better. Zoom fit works pretty well. And so if we hit trace now, we can trace values that are very close to 0. And so you can see we're very close to 0 right now, 0.15, and we can see what the y value is. As we get farther away, we can see we can get farther away from what the limit would be at 0. But if we actually put in 0, you can see it's not defined. And so the function is not defined at 0, but the limit is. And you can see that it is approaching the same value from the left and the right. So you can do it just from the graph like that, by tracing in values. Or you can type in your own values very, very close to 0. So you can say negative 0.0001, something like that, and hit enter. And you can see it's very, very close to 0.5. Or we can put in positive value, 0.000001. So we can get as close as we want to. And you can see that it gets very, very close to a defined function value. But at 0, we don't get anything. Now, another cool thing is we can come up with a table of values instead of like finding all the values through trace. So this table here, which is second table, looks something like that. You can see there's an error at 0. But what we probably want to do is get values very close to 0 from the left and the right. So the way you control that is through the table set, which is second F2. And so we can choose where the table starts. And so we could say at negative 0.9. And then we can say for the change, like how much we want to increment in the table of values, could be 100.01. So therefore, it's going to start at negative 0.9. It's going to go up 100th every time. And let's see what our table looks like now after doing that. And so now, as you can see, we can scroll down. You can see what it's getting close to. As you get, oh, I see it's going down. And it's not going up, is it? Oh, it is goes up too. Okay, good. And so there it is at negative 1.01 gives us an error. Yeah, so you can't go beyond negative 1. But let's see what happens as we get closer and closer to 0. And we can keep clicking, and see what happens. Ooh, that's a lot of clicking. Maybe I should have chose to be a little closer. But the point is, it'll keep giving you the values. You just keep going down and get all the values all around it. At 0, we have an error. And then you can see we have values around 0, 100th off each time. So I probably didn't choose the best values there to do what I'm trying to do. It probably would be better to have chosen to be closer to 0 than 0.9. And I could use even smaller increments than 100th to go up and down. But anyhow, you can choose to get any values you want with any increments you want by using this table feature. But the graph is nice itself because in the graph, you can actually see it visually, which is nice. You can trace, and you can also like put in any values you want and see what's happening there. So that's how you use your calculator to find limits analytically as opposed to algebraically. And it can be a very useful tool.